Good morning. This is my name's Brian Seroney, ICT trainer, Moiben Technical and Vocational College. Today I'm going to take you through about computer networking. This is a topic under networking in ICT. So let's check what we are going to do. We are going to start with network topologies. So we can, in brief, we can check on the definition of terms used in network topologies. First of all, we have a topology. Topology is the physical, logical network layout. The physical is the actual layout of the computer cables and other network devices. In a network setup. So normally we have the computers, that's normally the nodes. Then we have cables. These are used to connect from one computer to another computer. And other network devices. Other network devices include the hub, the switch. As we progress, we shall be checking those devices which are used to connect the computer and cables on the actual layout. Let's move on to logical. Logical is the way in which the network appears. So logical is the appearance of the devices, because you can have the devices arranged in a certain manner, but we have the common topologies that we have in a computer network setup, and the common ones is the bus. You can represent it in the term of the normal bus. Bus has two tires on one side and two tires on the other side. So the passenger is like the data moving from one location to another. Then we have the ring. The ring is in a circular motion, like the normal ring that you know. So the data will be moving in a circular way from one destination to the next. Then we move on to the star. The star is the layout in which the physical layout which has been, which the devices appears. So for a case, it appears like the star, where we have one device at one point, other device at one point. So the devices keep crisscrossing, forming a star layout. So we have the next one, we have the mesh. Mesh is like the wire mesh, where you have devices connected from one location to another, and the cable keep crisscrossing from one point to another until a mesh layout appears. So the devices are placed in different locations, but the appearance of the layout looks like a mesh. The last one that we have is the wireless. The wireless is like the mobile phone. Mobile phone, you can have mobile phones at different locations. Let's call this A, location A, this location B. So somebody having a mobile phone here, another person having a mobile phone in location B, they can communicate using wireless, where they don't have to have a logical connection of cables, but it's wireless, where they can converse and message can move from point A to B using wireless network. Okay, so let's move on to check on the bus topology. On bus topology, we are using a trunk or a backbone which computers are connected. This is the backbone means the main network that connects to the nodes, and our nodes for this case is the computers. So that's called a trunk. Normally we use the trunk because it's connected on from office 1, which is maybe finance, to office B, maybe administration office, maybe principal's office, procurement office. So computers are connected in a bus topology, not necessarily in that bus network, but different location in a network. So the system connected to this backbone use a T connectors. T connectors is the way they are connected to the trunk. The main line is called the backbone, and then the nodes is our computers. This is the node, this is our computer. So the way it's connected to the backbone, because this is the node 1 PC, this is the main backbone. So at this point it's connected in the T connectors or taps. It's connected in a T setup. Okay, so we can move on to see the figure. This figure shows how it's connected. It's connected using the nodes are connected from one point, then the other one are connected from one point. The connection point is the T connectors. These the T connectors where it's connected. The nodes are the PC, which is personal computer. It can be laptop, it can be tablet, as long as it's connected. So these are the nodes. Our PC is connected using the backbone. This is the backbone. This is our backbone. Our backbone is this one. T connectors are this one. So the setup here can be procurement, this is administration, this is principal office, this is finance. From the picture it appears like a bus, but for a case when it's distributed on different departments, this is how it is set up. But the logical appearance is bus topology. Okay, thank you. I think you're getting something on that. Let's move on to ring topology. Ring topology is a logical ring, meaning the data travels in a circular motion or circular version from one computer to the other. The typical technology that we have for implementing this ring topology, we have the fiber distributed data, then we have the SONET, and we have the token ring. These are technology for ring topology that is currently being used. Okay, can move on to see ring are mostly commonly wired in a star configuration. Token ring has a multi-station access unit equivalent to hub and switch. Hub and switch are two similar devices doing the same function, where it performs the circulation of data within a token circulation setup. You can see on this diagram, this is our node, this is another node, this is another node, this is another node. So these nodes represent, this one can represent finance department, this can represent administration department, this can represent this can represent a principal office, and this can represent procurement department. So for this case, this data will be moving in a circular version from one point to another, can move from another location. So this is how token ring function and how data moves. So it's a simple setup. Data will move from one point to another. So let's move to star topology. star topology is a bit different. All computers are connected to a central device called hub or switch. Hub and switch does the same task. It's a central device that distributes the LAN cables to be accessed by the nodes. Our nodes, in this case, is the computers or the personal computer. Each device requires a single cable, point-to-point connection between the device and the hub or device or the switch for this case. So we have two devices here. We have the hub and we have the computers. So these devices are connected using a single cable. So we move on. We shall see how it's connected in a diagram. So mostly it's widely implemented because it's easy to manage this setup. In case of maybe there's data failure, the setup breaks down, you can easily manage because it's a single point of failure. Because if you have a hub here, it's connected to a PC. It's connected to a PC. So this is a hub, this is a personal computer. So it's connected single point. So it's easy in case you have a failure. You can just troubleshoot each. You can have other devices connected. So in case you have a failure maybe here, you can easily manage. So from our diagram we can see how it's look like. This is the diagram, this is the hub that I was talking about, this is the nodes, this our case is personal computer. These are personal computers. Okay, personal computers. These computers here can be principal office, here can be procurement, administration, finance. This is just the logical setup of how the topology looks like. But just in case, in a setup of a school, a college, the device can be in different location, but the setup is a star. So this is our hub or switch. That's why I was saying it's easy to, in case of failure, you can just troubleshoot this one. If you have a failure on this, you cannot access this. This one you can have a problem here, but this one is still working, this is still working, this is still working here. So it's easy for you because you can just troubleshoot this network. Okay, that's star topology. I think you're getting something out of this. Let's move on to mesh topology. Mesh topology, you have in details each computer connects to each other, or every other computer is connected to each other. The challenge that we have in this is high level of redundancy, because if one computer is connected to another computer, and then you have this computer connected to this one, another through another network, through another network, through another network. So the layout is a bit meshy. So these are computers connection. These are computers connection. This one, this one, this one. So the challenge of high level of redundancy is where you see there's a cable connecting this one to this one, and there's also a cable connecting this one to this one. So there is a repetition. That means redundancy. So another thing is it's rarely used. I think it's rarely used because of the problem you encounter when you're using this type of network topology called mesh. Then another thing is wiring is complicated. I think you can just see this is another PC, this is another PC, this is another PC, this is another PC. You can see how the cables are running. This one runs to here, this one runs to here, this one runs to this one, this one runs to this one. So it's a bit complicated, and wiring is a bit tedious, and you may encounter a lot of problems when you are doing the cabling. Another thing is the cabling cost. Cabling cost, it's very high because you already connected this computer to a network, even this network, but now you're still running the same network with another same cable, which makes it expensive and with high cost. So it's not a good type, but for some situation you might need to use it, but it's a bit of high cost. So when you have a challenge in this network, the challenge that you have is troubleshooting, because you have said it's a mesh. So all the cable are crisscrossing. So in case you have a problem in one node, maybe you have 1 year, 1 year, 1 year, and 1 year. So you might have a challenge of troubleshooting. If you have a problem here, another problem here, you might not know which cable caused the problem along here. You might not know which cable, because cables are crisscrossing, forming a mesh setup. So this hybrid mesh variation creates a point connection between specific network devices. It's often seen in one implementation. One implementation is wide area network. When we have a very wide network, you can implement this as a setup, because you have to connect all the nodes or computers to a network. So this you can use hybrid mesh variation. So this is the type of setup. You can see it in a diagram. This is one node. This is one node, another node, another node, another node, another node, another node. So this one can be library, administration, principal office, procurement office, finance office. This is ICT department. So you can see all these nodes are connected using a network over mesh, where you withdraw a cable from the nearest destination. So in the process of this, you reach a point where you form a mesh. This is a mesh setup. Okay, so that's all about network topologies. I think you've learned something. So I will leave you with the assignment. Each student should draw diagrams of all the above discussed topology in their respective exercise book, so that we can come and discuss. Thank you for your time. I think you enjoyed. Bye.